Hello everyone, good afternoon to all of you and welcome at English Medium Prep by Exampur, and I'm Kumar Ravi. Guys, welcome to all the students. Today we will discuss some other topics from the same chapter as we were discussing, and guys, first of all you will have to do one thing, and that is just to like this video and share this video among all your friends. And if you have not subscribed this YouTube channel, then please subscribe this YouTube channel so that whenever we go live, then at least you can watch my lectures. Okay, so okay guys, so welcome to all of you. Let me see your comments. Yes, we will study current electricity chapter as we were already studying. Okay, so we will discuss the same chapters. Okay. We will discuss. Okay. So now guys, current electricity is the chapter, and we have already covered the Ohm's law, but today we will cover the resistivity. Oh, yesterday we too have covered the resistivity, but today we will see that the resistivity of the metallic wire does not depend upon the length of the wire and cross-sectional area of the wire. We have already covered that resistivity of the metallic wire depends only on the material, the nature of metal, the nature of metal. Okay. Okay. So guys, let's study about the resistivity of the material. Resistivity of material. Resistivity of material. Resistivity of material. Okay. So, my dear students, we have already derived this formula, and we all know that we have derived this formula, and we already know that resistivity of the material is R is equal to rho into L upon A. R is equal to rho into L upon A. Okay, where L is the length of the wire, where L is the length of the wire, and A is the cross sectional area. A is the cross sectional area. Okay, so here suppose that if L is equal to 1 meter and A is equal to 1 meter square, A is equal to 1 meter square. Okay, A is equal to 1 meter, L is equal to 1 meter and A is equal to 1 meter square, then R is equal to rho. It means the resistivity of the material can be defined as yes, resistivity of the material can be defined as this. Resistivity of the material can be defined as this resistance. Okay, so resistivity. So guys, here we can see that resistivity of a material is equal to the resistance of a wire having the length 1 meter and area, cross sectional area 1 meter square. Okay, so this will be this resistivity of a metallic wire. Resistivity of metallic wire is equal to the resistance of resistivity of a metallic wire is equal to the resistance of wire having length 1 meter and 1 meter square. And 1 meter square. And 1 meter square. Okay, so it means suppose that we should write as suppose that these are the three conductors. Suppose that these are three conductors like this. Okay, so these are three conductors, and suppose that this conductor is made of aluminum, this is copper, and this is suppose that this is made of gold. Okay, suppose that this is made of gold, this is copper, and this is aluminum. Okay, so suppose that this is not of gold, this is of silver. Suppose that this is of silver. Okay, and this is of aluminum, and this is of aluminum. Okay, so this is silver, matlab chandi. Okay, now suppose that the length of these metallic wires is 1 meter. Length is 1 meter. Length is 1 meter. Its length is 1 meter, and its length is also 1 meter. Okay, so this one is also 1 meter. Okay, so 1 meter, 1 meter, and 1 meter. Okay, now the cross sectional area is 1 meter square. Okay, the cross sectional area of this one is also 1 meter square. Okay, now the cross sectional area of this one is also 1 meter square. Okay, so these are 1 meter square the cross sectional area. Length of all these wire is this. Okay, so we will write we will write the resistance of this formula RAL. Okay, resistance of aluminium, that will be equal to resistivity of aluminium into length upon area, and both of these quantities equal to 1. Okay, so this is equal to 1, this is equal to 1. Okay, so now for this also, for copper also, for copper, R copper, this one will be equal to into this. Okay, and Ag, in case of Ag, and this will be equal to R Ag, yeah, R Ag, and this will be equal to rho Ag, rho Ag. Okay, so these will be the resistances. Guys, if we know that all these three wires have the resistance which is not equal to each other. The resistance of all these three wires are not equal to each other. It means here we can say that RCU is not equal to RAL. This is not equal to RAG. Okay, this is not equal to RAG. So here we can see that if these three are not equal to each other, then obviously the rho will not be equal to each other. Okay, so these three will not be equal to each other. Rho Cu will not be equal to rho Al, cannot be equal to rho Ag. Okay, yes. So these are the resistivities of all these three materials. Okay, so these are the resistivities of all these three materials. Okay, so these are the resistivities of all three materials. Hence we can say that resistivity of any material does not depend upon the length as well as the cross sectional area. If it was depending upon the length and cross sectional area of the wire, then obviously here you can see that the cross sectional area and the length of the length of these wires is equal. Okay, hence the resistance of all these three wires should be equal, but it is not so. Okay, so we can say that we can say that we can say that resistivity resistivity does not depend upon yes, resistivity does not depend upon resistivity does not depend upon length and cross sectional area. Okay, so guys, if you are watching this live plan, then please do like this session and share this session among all your friends. So I have proved that resistivity of any material does not depend upon the length of the wire and cross sectional area of the wire. It depends only on the nature of the material and the temperature. Okay, and this depends upon temperature also. Okay, actually this is the formula of resistivity. Okay, we have already gone through it. 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 Okay, so this is the proof. Okay, so guys, if you are watching this live, then please do like this session and share this session among all your friends. Yes. Okay, so this is the resistivity. Now suppose you have been given a metallic wire of length A, of length L, and cross sectional area A. Suppose that if you have stretched this wire like this, and now the length has been increased by n times. Okay, so the length becomes n times the previous value. Okay, suppose that initially it was of 1 meter and now it is n meter. Okay, so the cross sectional area of this wire will become less, because the volume of the total material will remain constant. Volume of the total material will remain constant. If the length has been increased, then obviously the cross sectional area will decrease, and hence, since we all know that the volume of the metallic wire will be equal to the volume of a cylinder. Okay, so will be equal to the volume of a cylinder, just like. Okay, so we can write it as, suppose that this is a metallic wire. Okay, suppose that this is a metallic wire, and now the metallic wire has been increased. Okay, now the metallic wire has been increased like this. If initially the length is L and cross sectional area is A, and now the length is n times, now the length is n times, now the length is n times. Okay, n times. Okay, now, and the cross sectional area will become A upon n, because here the volume, we all know that the volume of this wire will be equal to L into A, and the volume of this wire will be equal to L into A. Hence you can see that the volume of both the wires is same. Volume of both the wires is same. Okay, so this has been done like this. Okay, so this has been done like this, and suppose that resistance is, this is R1 and resistance of this wire is R2. Okay, rho will remain same. Okay, so the resistance of these materials is R1 and R2. Okay, So the resistivity of both the materials will remain same, because we have just stretched this wire, we have not changed the material. Okay, so that's why the resistivity will remain same. So the resistance of old wire, that will be equal to, resistance of old wire R1, that will be equal to rho into L upon A. That will be equal to R1 will be equal to rho into L upon A. Okay, and here R2 will be equal to rho into L2 upon, yeah, N into L. Okay, N into L, N into L, N into L, N into L upon A upon N. Okay, so this is A upon N. Guys, here we can see that R2 will be equal to, and this will be equal to rho into N square into N square upon A into L. Okay, so here you can see that N square into rho into L upon A. Okay, so this will be equal to this. Okay, so R2 will be equal to N square, R2 will be equal to N square into L upon N. This will be equal to R1. Okay, so this will be equal to R1. So this will be equal to R1. Okay, now, so here we can see that the resistance of metallic wire, here we can see that the resistance of this metallic wire has become N square times, okay, than the previous value. The resistance of this metallic wire has become N square times than the previous value. Okay, so this is the actually basic thing. Okay, so this is the final result. Okay, and we all know that if a metallic wire is stretched, and length become n times the previous value, n times the previous value, n times the previous value. N times the previous value. Okay, then resistance becomes n square times. Resistance becomes n square times. Okay, so this is the result. Now please note it. You can note it. Okay, so this is the result. Actually, the question based upon this formula has already been asked in different examinations like CHSL and some many other exams. Okay, CHSL and some many other exams. So guys, just write down this. Okay, now we will move to other Now we will move to an example. We will move to another example, as well as I will tell you that what is the effect of the temperature, what is the effect of the temperature on the resistivity. Okay, so suppose that there is a question, resistance of a metallic wire, resistance of a metallic wire, resistance of a metallic wire resistance of a metallic wire is resistance of a metallic wire is 12 ohms. 12 ohms. Okay, if the wire is melted, if the wire is melted and recasted into a new wire, recasted into a new wire of length of length 4 times, then calculate the length calculate the resistance of wire. So this is the example actually. Now calculate the correct answer actually. Okay, I know that you can calculate very easily because this one is one of the very simplest examples. Okay, so you can calculate it very easily because this is one of the simplest examples. Okay, so calculate it. Yes. So this is the example of metallic wire. Actually, solution. Okay, so what should be the solution? So what will be the solution? What will be the solution? Solution will be like this. If the initial length is equal to L. Okay. Now the final length is equal to 4L. Final length is equal to the 4L. Final length is equal to 4L. Okay. And suppose that the initial resistance is equal to 12 ohms. 12 ohms. And 12 ohms, and now you will have to find out R2, and this is equal to what? Okay, so R2 will be equal to N square into R1, and this is equal to 4 square. Okay, so this will be equal to 4 square into R1, and this will be equal to R2, and R2 will be equal to 16 times 12. Okay, and this will be the correct answer because initially the resistance is equal to the 12 ohms. Okay, So 16 to the 32. 16 into 16 or 3 19. So this is 190 ohms. 192 ohms. So this will be the correct answer. Okay. So please write down and note it down in your notes. Yes. Please note. Okay. So these are the questions. So such type of questions are asked in examination, and let us know that the dependence of temperature on the resistance. So dependence of temperature on the resistance. Please note. So guys, this is one of the example, and now we will see that the dependence of the resistance on the temperature. Okay. So dependency of temperature on resistance. On resistance. Yes. Dependency of temperature on resistance. Yes, dependency of temperature on resistance. So when we talk about the dependency of temperature on resistance, then RT, suppose that if we talk about R0, this is the resistance at 0 degrees Celsius. Resistance at 0 degrees Celsius. Okay. And RT, resistance as T degrees Celsius. Okay. So alpha, this is the temperature coefficient of resistance. Temperature coefficient of resistance. Temperature coefficient of resistance. Okay. So this is RT, and RT will be equal to R naught into 1 plus alpha into T. Okay. So this is the formula. So this is the formula actually. Okay. So this is the formula. Okay. So this is the formula. You can see it. Okay. So you can see it. So this is the formula. And here you can see that this alpha is very, very important. In case of metals, in case of metals, alpha is positive, but for semiconductors, alpha is negative. Alpha is negative. Okay. So this is alpha and this one is alpha. So these are very important things. Okay. So these are very important things actually. Note it down. Note it down. Okay. So this is the result. Okay. So these are very important things. I'm sure that you will get at least one question from this lecture. You will get at least one question from this section in your exam. Okay. So please note. And now later on we will do some more questions. Okay. Similar results, similar formula is for resistivity also. Okay. So rho t, and this is equal to rho 0 into 1 plus alpha into t. Okay. So this is rho t. Now let's move ahead. What is the resistance of the metallic wire having VI characteristic? Okay. So resistance from VI characteristic. Resistance from VI characteristic. Resistance from VI characteristics. Okay. Resistance from VI characteristics and resistance from VI characteristics. Yes, guys, see that this is suppose that this is okay. This is VI. Okay, this is VI. Okay, and now yes, this is VI. So here first of all we will see that this is a curve. Okay, suppose that this is a curve and these are the values like this. Okay, so these are the values, these are some values, and suppose that this is 20 volts. Oh, suppose that these are 20 volts, 20 volts, and this is 2 ampere. Okay, and this is 2 ampere, and this is 2 ampere. Okay, so this is V and I, and now we can easily calculate. So here we can easily calculate. So here we can easily calculate this value of theta. Here we can easily calculate this value of theta. Okay, so resistance R, and this will be equal to V upon I. Okay, so R will be equal to tan theta, and this will be equal to what? And this will be equal to 20 upon 2, and this will be equal to 10 ohms. 10 ohms. So please write down, this is the correct answer. So please write down, and this is the correct answer. Okay, so such type of questions are asked in different examinations like SSC, CHSL, Indian Railways, or UPSC, CDS, and CPO. Okay, so these are some very basic questions from electricity. Okay, so guys, today we will finish this lecture at this point, and now tomorrow onwards we will learn some more questions based upon the applications of electricity. I believe that you have noted down all these things. Okay, so again you can just revise that we have gone through this. We have gone through these points today, and these are very much important points. And you will see at least one or two questions. Okay, so guys, one thing I would like to tell you that apart from the YouTube sessions, we also teach on on our application actually. Okay, we have an official application of Exampur named by Exampur official. Okay, so this is the official application Exampur Sarkari Nokri Prep. You will have to download from the Play Store. Okay, just type Exampur and then you will find out such kind of logo. Okay, then after you will see the name of this Sarkari Nokri Prep Exampur, and just install into your phone, and after installing just open it. Okay, when you will open it, then you will find two types of options. Number one, register here and login. Okay, if you have already registered, okay, then you must log in that and find out the suitable course for you, okay, that you want to prepare for, and then you can join very easily by after paying a very small amount of fees. if you have not downloaded that earlier and you have not registered on our application, then you can just register on this application, and you will find some such application form here, and by just filling that application form you can just register yourself. Okay, so you can just register yourself like this. Okay, and after registering you can just log in, and after login you will find there different types of categories, and in each type of category you will find so many batches. Okay, but any one or two batches you will have to join. Okay, so in our paid batches you will find the video lectures from very basic to the advanced level, and we will also provide you the PDF notes. Okay, as well as the previous year's questions discussion video, previous year's questions solution PDF. Okay, solution question answer discussion PDF notes, as well as mock test. Okay, test series. So all these stuffs will be given in the paid batches, so that you can prepare in a very good manner, in a very good way, and within a short span of time you can achieve your goal. Okay, so this will be the application which will be providing you a lot of things. Okay, so I will suggest you to download this right now. And guys, those who are on the first who are visiting this YouTube channel the first time, then please just subscribe this channel and share this video among all your friends. Okay, I teach 10 a.m. in the morning and 2 p.m. in the noon, and I just cover all the sessions. Okay, all the topics, and I teach theory portion at 2 p.m. and the numerical or the MCQ section at morning session. Okay, so guys, it's today, and it's for today, and tomorrow we will meet at the same time, 2 p.m. Thank you so much. Have a nice day. Bye bye.